So, welcome to the lecture series on mathematical methods and its applications. Now we will discuss Fourier sine and cosine transforms. We have already seen what Fourier transforms are. We have seen that Fourier transform is given by Fourier transform of function ft is given by minus infinity plus infinity ft e की power minus eta omega t dt, which is f omega, and its inverse which is f omega, inverse of f omega is ft, which is given by 1 upon 2 pi integral minus plus infinity it is f omega e की power eta omega t d omega. So, that is how we can find out inverse Fourier transform and Fourier transform of ft. Now, sine and cosine transforms. Before discussing sine and cosine transform, let us discuss shifting property of Fourier transform also. So, suppose Fourier transform ft is of omega and omega naught is belongs to R. Then Fourier transform of is a very simple property e की power eta omega naught t into ft. Let us find Fourier transform of this. So, Fourier transform of this is nothing but minus infinity plus infinity. You apply definition, okay, this definition e की power eta omega naught t into ft into e की power minus eta omega t dt. So, this is given by minus infinity plus infinity ft e की power minus eta omega minus omega naught into t into dt. So, in this expression, instead of omega we have omega minus omega naught. So, this is nothing but f of omega minus omega naught. So, this is called shifting property, I mean frequency shifting property of Fourier transforms. So, this we can use sometime while solving some problems. Okay. Now, next is Fourier cosine transform. The Fourier cosine transform function ft is defined as 0 to infinity ft cos omega t dt, which is given as Fourier cosine transform of ft. Now, it comes from basically from Fourier cosine integral representation of function ft. What is the Fourier cosine integral representation of function ft? It is ft is equals to 1 upon pi integral 0 to infinity, it is a omega cos omega t d omega, where a omega is given by this expression. Okay. Now, if you compare 1 and 3, so a omega is nothing but 2 times f c omega when you compare these two. Okay. So, when you substitute it here, so we obtain ft equal to this, which is called inverse Fourier cosine transform of ft. So, what is the Fourier cosine transform and what is its inverse? So, basically Fourier cosine transform of ft is given by, it is 0 to infinity ft e की power minus eta omega t dt, which is a Fourier cosine transform of, okay, because okay, it is cosine. So, it contains cosine terms, it is ft into cos omega t dt, which we are calling as Fourier cosine transform, or it is we are calling as f c omega. Okay, we are calling it f c omega. Okay. Now, the inverse of this is given by inverse of Fourier cosine transform is given by, it is 2 upon pi integral 0 to infinity ft, it is f c omega, yeah, it is f c omega cos omega t dt d omega. So, this will be the inverse Fourier transform of inverse Fourier cosine transform of ft. Okay. Now, similarly, if we define Fourier sine transform, So, Fourier sine transform is given by 0 to infinity f t sin omega t dt, which we denote as f s of omega, and it comes from Fourier sine integral representation of f t, because we know that Fourier sine integral representation of function f t is given by this expression where b omega is this. Now, if you compare this with this expression, so b omega is nothing but 2 times f s omega. Okay. So, if you substitute this expression b omega 2 times f s omega over here, over here, so it will be 2 upon pi times 0 to infinity f s omega sin omega t dt. So, what is the Fourier sine integral representation of function? Fourier sine integral representation of function f t will be nothing but it is 0 to infinity f t sin omega t dt, which we are given as Fourier sine integral representation denoted by this expression, and the inverse of Fourier sine transform of f t will be nothing but 2 upon pi times integral 0 to infinity f s omega sin omega t into d omega, which is nothing but f t. Okay. So, now let us find out Fourier sine and cosine transform of this function. Okay. So, suppose you find f x is what? F x is given as k when 0 less than x less than a, and is 0 when x is greater than a. So, suppose you want to find out Fourier cosine transform of this function. So, this will be equal to 0 to infinity f t is okay, f t cos omega t dt, which is equals to 0 to a, it is k into cos omega t dt, which is equals to k. Now, when you integrate this, it is sin omega t upon omega from 0 to a, which is nothing but k upon omega sin omega a. So, this is basically Fourier cosine transform of this function f t. Now, similarly, if you want to find out Fourier sine transform of this function, so Fourier sine transform of this function f t will be nothing but again 0 to infinity f t sin omega t into dt, which is equals to 0 to a f t is k sin omega t into dt, which is equal to k can come out, it is minus cos omega t upon omega from 0 to a, it is minus k upon omega times it is cos omega a to minus 1. So, it is k upon omega times 1 minus cos a. So, this will be the Fourier sine transform of this function f t. So, in this way we can find out Fourier cosine or Fourier sine transform of any function f t using these expressions. Okay. Now, Fourier transforms also satisfy some properties. What are they? Now, first of all, the existence condition, if f x is absolutely integrable on a positive side of x axis and piecewise continuous in every finite interval, then the Fourier cosine and sine transform of f exist. So, this is the condition that function must be absolutely integrable on the positive side of x axis and it must be piecewise continuous, then Fourier sine and cosine transform of function will exist. Now, the first property is Fourier cosine and sine transform also satisfy linearity property. So, this property is also satisfied, that we can easily see also, that is easy to prove basically. What is Fourier cosine transform of suppose a f plus b g? It is nothing but by definition it is 0 to infinity a f plus b g into cos omega t dt. So, that will be nothing but a times 0 to infinity f into cos omega t dt. This f is a function of t, g is a function of t, plus b times 0 to infinity g cos omega t into dt. So, this is nothing but A times Fc of Ft, and this is plus B times Fc of Gt. So, hence Fourier cosine transform satisfy linearity property. Similarly, we can show that Fourier sine transform also satisfy linearity property. Okay, the first thing. The second thing is cosine and sine transform derivatives. Now, a function is continuous and absolutely integrable on the positive side of x axis, and f dash is piecewise continuous on each finite interval. Okay. And suppose f x tends to 0 as x tends to infinity, then these two results hold. Now, let us derive these results. So, what is Fourier cosine transform of f dash x? That will be nothing but by the definition or ft or fx, you can say anything, that will be a 0 to infinity f dash t into cos omega t into dt. This is by the definition of Fourier cosine transform. You simply replace f by f dash in this expression. Okay. So, that will be given by is equal to. Now, you apply integration by parts, you take it first function and you take a second function, first as it is. Now, integration of second, it is f t from 0 to infinity minus integration derivative of first is omega sine omega t with negative sign, the negative positive, and it is f t dt. Now, when you take upper limit, now this we have assumed that as x tending to infinity or t tend to infinity, f x tend to 0. So, as t tend to infinity, this will tend to 0. So, 0 into some finite quantity will be 0, and that will be, it is nothing but 0 minus f 0, because when t is 0 it is f 0 plus omega times integral 0 to infinity, it is sine omega t into f t dt. Okay. So, this is nothing but omega will come here, this omega, and this is nothing but Fourier sine transform of f t. Okay. This is Fourier sine transform of f t. So, this is Fourier sine transform of f t minus f 0. So, this is the derivation for the first part, that the Fourier derivative of Fourier cosine transform of f will be nothing but omega times Fourier sine transform of f t minus f 0. Okay. Now, second part, Fourier sine transform of f dash x. So, Fourier sine transform of f dash x or t is nothing but 0 to infinity f dash t into sine omega t dt. This is by definition of Fourier sine transform. You simply replace f by f dash t in this expression. Now, you again apply integration by parts, it is 1, it is 2. It is first as it is, integration of second from 0 to infinity minus integral derivative of first is omega cos omega t into f t dt. So, when t tend to 0, when t tend to infinity, f t tend to 0, this is by the assumption. Okay. So, this tend to 0. Now, when t is 0, sin 0 is 0. So, we have 0 here from both the limits, minus omega will come out, it is 0 to infinity cos omega t into f t dt. So, this is minus omega times, this is nothing but Fourier cosine transform of f t, so it is Fourier cosine transform of f t. So, this is how we can obtain the Fourier derivative of Fourier sine transform, which is nothing but minus omega time Fourier cosine transform of f t. Now, suppose you want to find out Fourier cosine transform of second derivatives. So, that also we can find out using the same result. Now, what is Fourier transform f dash Fourier cosine transform f dash x? Fourier cosine transform f dash x is nothing but, or f dash t is nothing but, this we have derived, it is omega times Fourier cosine transform of f dash f x minus f 0. Okay. This we have derived. Next is Fourier sine transform of f dash Fourier sine transform of f dash t is nothing but minus omega Fourier sine transform of Fourier cosine transform of f t. So, these expressions we have just derived. Suppose now we want to find out Fourier cosine transform of double derivative of at t. This we want to find out. Okay. It is Fourier cosine, so it must be sine. Okay. Now, suppose you want to find out Fourier cosine transform of second derivative of f at t. So, this will be nothing but, now you simply replace f by f dash in this expression. So, when you replace f by f dash in this expression, so Fourier cosine transform of f double dash t will be nothing but omega times Fourier sine transform of f double dash f dash t. You are replacing f by f dash t. So, it is f dash t minus f dash 0, which is equals to omega times. Now, Fourier sine transform of f dash t is, we already know, it is minus omega Fourier minus omega Fourier cosine transform of f t minus f dash 0. So, when you simplify, it is nothing but minus omega square Fourier cosine transform of f t minus f dash 0. So, this will be the Fourier cosine transform of second derivative of f. Now, similarly, if you want to find out Fourier sine transform of second derivative of f, so that also we can find out. Now, in this expression, you simply replace f by f dash. When you replace f by f dash in this expression, it is minus omega Fourier cosine transform of f dash t. Now, this is equals to minus omega. Now, Fourier cosine transform of f dash t from this expression is nothing, you can simply substitute it here, it is omega Fourier sine transform of f t minus f 0. So, that will be nothing but minus omega square Fourier sine transform of f t minus omega f 0. Okay. So, okay, it is minus omega square into minus minus plus. Okay. So, it is really plus. So, in this way we can obtain the Fourier transform of second derivative of f or the Fourier sine transform of second derivative of f. So, similarly, if you want to obtain the Fourier cosine or sine transform of third derivatives or the higher derivatives, so that also we can obtain using the same concept. Okay. So, this is how we can find out Fourier sine or cosine transform of function if a function is known to us, and how we can find out Fourier sine or cosine derivatives, that also we have seen, or the higher order derivatives, that also we have seen. So, next in the next lecture we will see some more properties of Fourier transform and how the problems can be solved on that we will see in next class. So, thank you very much.